Okay, essential question. I actually have two for today's lesson. So essential question 1, what is the relationship between exponents and logarithms? Okay, so just a couple things to note. Logarithms can be written as exponents. Okay, so there are some interchangeable characteristics between the two. Okay, one of the things that is similar is that the base of the logarithm is the base of the exponent. Okay, so that's an important piece. So remember, when you're looking at an exponent, the base of the exponent is this big number here. Okay, that's the base. Okay, this is called the exponent. The whole thing, 4 to the third, is called a power. Okay, the whole thing together is a power. And then our solution is the 64. Okay. So if you're doing some interchanging between logarithms and exponents, one of the things to note is that the base of the logarithm is the base of the exponent. So the next slide. So how to rewrite logarithmic equation. This is what logs look like. So the first one, log base 2 of 8 is equal to 3. So we've already noted that the base of the log would also be the base of the exponent. So that's the base. Now look at our other numbers. Note the exponential form. Look at the exponent of the exponential form, and where is it located with our logarithm? Okay, it's the answer, right? So this happens to be the exponent part. So when we're trying to solve a logarithm problem, which we are going to do later, we're looking at 2 to what power equals 8? And then the answer would be 3. 2 to the third power equals 8. Okay, so rewriting this, the base is 2. My exponent is the solution of the log, and that equals 8. You can see that in the others. So here's my base. 4 to the 0 power equals 1. On the next slide, you're going to practice just rewriting. All right, so there's some logarithm equations. Rewrite them in exponential form. All right, let's check some of those. So we have 3 to the 4th power equals 81. Remember, the base of your log becomes the base of your exponent format. Okay, the answer to your logarithm becomes the exponent of the exponential form. Okay. And then the other number is your solution to the exponential. So 3 to the 4th power equals 81. Next, 7 to the 1st equals 7. 4 1/2 to the negative 5th equals 32. Okay, remember what the negative exponent does to the fraction. Okay, and then raise it to the 5th power. Number 3, 14 to the 0 power equals 1. All right. Next, let's look at how we evaluate logarithms. Okay. So when you're trying to find the answer to a logarithm problem, it's helpful to think of it as an exponential, in exponential form. So if I'm looking at A, log base 4 of 64, I want to find out what that's equal to. So you can rewrite it as an exponent. So the base of your log becomes the base of your exponent. The answer to your log problem, which is what we're trying to find, is the exponent. So what we're trying to do is figure out 4 to what power equals 64. Okay. And in this case, 4 to the 3rd power equals 64. So the answer to your logarithm is 3. Part B, 5 to what power is 0.2? Now, if you have decimals, I'd recommend writing them as fractions because then it's kind of helpful. Okay, makes it a little easier to work with. So I'd probably rewrite this log base 5 to the 1/5, because remember 0.2 is the same as 2 over 10, which simplifies to 1/5. So log base 5 of 1/5 is equal to what? So that's asking 5 to what power equals 1/5. Okay. So think, how can I get the 5 into the denominator? What kind of exponent am I going to have? It's going to be negative. That's how we get a fraction. And to what power? 1. Okay. So log base 5 of 0.2 is -1. The last one, log base 1/5. Trying to figure out raised to what power. That's what we're looking for. What power is 125? So again, on this side, it's in fraction form, and the 5 is in the denominator. On the right-hand side, there is no fraction. So what kind of exponent would you have? A negative. Okay, gets it out of the fraction that way. And 5 to what power gives me the 125? 3. So it's going to be a -3. Now you get to practice some. Okay, so log base 2 of 32. 2 to what power gives me 32? So what's the answer? So the answer is 5. Log base 2 of 32 is 5. Log base 27 of 3 is what? So you want to think of 27 to what power equals 3. So I'm trying to find that power. 1/3. Remember, if you raise something to a fraction power, the denominator becomes your root. So that means cube root of 27. And what is the cube root of 27? 3. Okay? 7. Log base 36 of 6 is what? So 36 to what power gives me a 6? So 36 to what power gives me a 6? So what does that exponent have to be? Okay. That one would be 1/2. Okay. So 6 squared is 36, but I'm looking at the 36. What do I raise the 36 to get the 6? So if you think, well, I have to take the square root of 36, that would give me 6. Then you can take that and change it to an exponent. Okay. Second essential question. We're looking at some other characteristics of logarithms. What types of logarithms are undefined, and what types are defined? So the first one, log base 3 of 1. So this becomes the base of our exponent. I want to know what is the power. 3 to what power equals 1? Let's look at the next one. 10 to what power equals 1? B to what power equals 1? So regardless of what the base is, the log of 1 is going to be 0, always. Let's look at the next one. Note here, the base, this base, and the number I'm taking the log of is the same. Okay, it's the same number. So 3 to what power equals 3? 10 to what power equals 10? And B to what power equals B? So when the base and the number you're taking the log of is the same, what's your answer going to be? 1. Next, looking at our patterns again, please pay attention to this one. So we're looking at our base. 3 to what power equals -1? Is there a power that we can raise the 3 to get -1? No, this is undefined. So let's look at the next one. 10 to what power is going to give me -5? Can I raise the 10 to a power and get -5? No, this is undefined. B to a power to equal negative 12? Nope, undefined. 7 to what power equals 0? Is there a number I can raise it to a power and get 0? No. So it works with negatives and the 0. You cannot take the log of any negative number, and you cannot take the log of 0, regardless of what the base is. It does not work. Okay, they are undefined. Okay. So when we're looking at fractions, you look at them the same way. We'll do number 1 together, and then I want to give you guys a chance to try to do the other ones, okay? The base of the log is the base of our exponential. So 2/3 to what power equals 4 over 9? Okay. So 2 to the second would equal 4, right? 3 to the second would equal 9. The 3's on bottom, the 9's on bottom. Everything's in the correct spots. So the answer is 2. That's not bad, right? Now, when we are dealing with fractions, sometimes you have to kind of match up the numbers and see which numbers go with which. Is there anything I can do with the 3, the number on top, to get a 64, which is my other number on top? Is the 3 and 64 anything really related to those? No. Now look at the number on bottom. Is 3 related to 27? Yeah, 3 to what power gives you 27? 3 to the third. Now, since the 27 is on bottom, what could I do with that third power to make the 3 go to the bottom? Make it a negative. Okay? So negative 3. So if you check 3 to the fourth raised to the negative third, because you can always check it, the negative tells you to flip it, and it becomes positive now. And then everything is raised to the third. So 4 to the third is 64, 3 to the third is 27, and that's what we have right there. Okay? Let's look at the 81 over 16. 81 over 16. So what can I do to the 81 to make it a 3? Like a fourth root. So it would be a 1/4. So if I raise it to the 1/4, the fourth root of 81 gives me 3. Does the fourth root of 16 give me 2? All right, so it's 1/4. Now here, does the 81 go with the 2 at all? No. But it would go with the 3, right? But the 3 is on the bottom. So what do I have to do with my exponent to make the 81? It's going to become negative, and what is that exponent going to be? That'll also be a 1/4. Let's take a look at some special logarithms. Log base 10 and log base e. These are the most common logarithms that are used. For log base 10, because it's so common, we usually just write it like this, where there is no number written. If there is no number written, that means it's log base 10. If it's log and then a number, or like x, log x, that means it's log base 10 of x. This is called common log or logarithm. If you haven't noticed already, I tend to abbreviate the word logarithm because it's such a long word, so I don't have to write it all the time, to just log. And that's standard. We all do that. So that's the common logarithm. If you were to write it in exponential form, the base would be base 10 to the y power equals x, if we convert this expression to that. The next one, the log base e. This is called the natural log. Another common one that's used, and typically it's abbreviated as ln. Okay? ln. N refers to the natural part, L for the logarithm. This is how you abbreviate log base e. So over here, if we were going to convert this, it'd be a base e. E is an actual number. Okay? So base e to the y power equals x. So that'd be the total conversion for that log base e. Some other nice characteristics. We can convert all your other log bases, so log base 5, log base 2, log base 20, log base 1/2, we can convert all of those other logarithms to a log base 10 or a log base c. So we are going to do that here in a little bit, where we'll do that conversion. I wanted to look at just a couple of examples. So I have log 2 equals x. How would we rewrite that? E to the x power equals 2. Log 100 equals 2. How would I rewrite that? It's like, right, so just seeing it with some actual numbers in there helps. So now we're going to evaluate. Okay, this is, remember back to some of the other characteristics that we saw. What's my base on that first one? 10, log base 10. And I'm taking the log of 10. So the base and the number are the same. So what's my log answer going to be? 1. 10 to the first power is 10. Okay, what about this one? What's the natural log of e? 1. Okay, remember that means e to what power equals e? So e to the first.